Hey, so today what we're going to look at is finding all zeros. So if you're given a function, like I'm given here, and you're going to also be given some additional information. In this case, we're given that f of 2 equals 0, okay? And so what we want to do is find all of the zeros. Well, one thing that you need to remember is that based on the fundamental theorem of algebra, the number of zeros equals the number is the degree. So if we look at this function and we recognize that our degree of this function is 3 because the highest exponent here is 3. So that means the degree is 3. Therefore, what that means is that there are going to be 3 zeros. Okay? Now they gave us one of them. One of our zeros is here, 2. 2 gives us 0. So 2 is one of the zeros. But there's 2 more that we have to find. So to find them, we're going to basically factor this function. Okay? So we're going to go and use synthetic division. Or start with synthetic division. Okay? So we're going to take our coefficients. So it's x cubed. So the coefficient of x cubed is 1. Of x squared is -4. Of x is 21. And our constant is -34. Okay? Now f of 2 equals 0. What this implies is that x minus 2 is one of our factors. Okay? So when we're going through the synthetic division, this will be 2. That's our r value that we've been talking about. Okay? So if you'll remember, the very first step is we're just going to bring down 1. Okay? And then we're going to multiply. So 2 times 1 is 2. Then what we're going to do is add. So -4 plus 2, so it's going to be -2. 2 times -2 is -4. And then again we're going to add 21 plus -4 is going to be 17. Again we're going to multiply. 2 times 17 is 34. And then again we add and we get 0, which makes sense. That's our remainder. And if f of 2 equals 0, then our remainder should be 0. And that's what we got. So when we now go to write this or factor this, we already know that x minus 2 is one of the factors. So we pulled that out. So f of x. So when we factor out x minus 2, factor out or divide out, it's the same thing. Factor out x minus 2, we're going to be left with 1x squared minus 2x plus 17. Okay? So we've got the 1 0 from this factor. So our other 2 zeros are going to come from this factor. So that means we've got to factor it, or we've got to find some way of solving for the other 0. And the way that we're going to do that, if we can factor it, we would go through factoring. This isn't one that can be factored though. So the way we're going to do that is we're going to use the quadratic formula. So the quadratic formula, if you'll remember, you need a. So in this case, a is 1. You'll need b, which is -2. and you'll need c, which is 17. And then we're going to go into the quadratic formula, which says the opposite of b, so the opposite of b plus or minus square root b squared minus 4 times a times c, all over 2 times a. Okay, so that's how we can find our other x's. We're going to use the quadratic formula. So I'm going to take my information and plug it in. So the opposite of b, well, b is -2, so the opposite of -2 is +2, plus or minus square root b squared, so -2 squared is 4, minus 4 times a times c all over 2 times a. Okay, and then we start simplifying. So we get 2 plus or minus square root, and this is going to be -64 over 2. And square root of 64 is 8, but because it's -64, it's going to be 8i, imaginary, divided by 2. And then we just kind of simplify this down. 2 divided by 2 is 1, plus or minus 8 divided by 2 is 4i. And this is two different zeros. So you have 1 plus 4i and 1 minus 4i. So when we look at our zeros, and again, remembering the fact that there's 3 of them, one of our zeros they gave us, which was 2. The other 2 zeros, we use the quadratic formula to find, and the other 2 zeros are 1 plus 4i and 1 minus 4i. Okay. So let's look at another example. In this one, we got, again, another polynomial, another function. And this time it tells us that x plus 9 is a factor of f of x. So if it's a factor, that means it goes into it evenly. That means the remainder is 0. So let's factor it out. So again, to factor it out, we're going to use synthetic division. So our coefficients are 5, 54, 85, and 36. And it's plus 9, so that means our R value is -9. Okay. So again, the first step will always be to just bring this first number down. We are going to multiply. So -9 times 5, -45. Then we're going to add. So 54 plus -45 is 9. Then we're going to multiply. So -9 times 9, -81. Then again, we're going to add. So 85 plus negative 81 is going to be 4. Negative 9 times 4 is going to be negative 36. And then again, we add and get 0, which makes sense, because if x plus 9 is a factor, that means there's no remainder. It's going to go into it evenly. Okay? So, I can rewrite f of x now as, so we've basically factored out x plus 9. And we're going to be left with 5x squared plus 9x plus 4. Okay. And then our next step is we're going to use the quadratic formula with this. So we know our a value is 5, our b value is 9, and our c value is 4. Okay? So, going into the quadratic formula, opposite of b, so negative 9, plus or minus square root, b squared minus 4 times a times c, all over 2 times a. Okay? And then we just simplify it down. So we got negative 9 plus or minus the square root. And let's see what we get under there. We're going to get 1. Two times 5 is 10. Okay. This is negative 9 plus or minus, and the square root of 1 is 1 over 10. So we're going to end up with real numbers here, because we didn't have a negative underneath our radical. So our answers are going to be real numbers. So we're going to find, so what we're going to do is negative 9 plus 1 over 10. So that's going to be negative 8 over 10, which reduces to negative 4/5. And then we're going to do negative 9 minus 1 over 10, which is going to be negative 10 over 10, which is going to be negative 1. So again, our polynomial is a third degree polynomial. So it means that we should have 3 zeros. One of our zeros is negative 9. And then our other 2 zeros are negative 4/5 and negative 1. So negative 9, negative 1, and negative 4/5.